All right, guys, let's go ahead and talk about isotopes. What we're going to do today is learn about isotopes. Now, we did learn about atomic structure. We learned how atoms have protons, neutrons, and electrons. And we learned that atoms are defined by the number of protons that they have. So, for example, if an atom has 6 protons, it's a carbon atom. If it has 7 protons, it's a nitrogen atom. However, what we're going to learn today is that two atoms of the same element will have the same number of protons, but they might have different number of neutrons, which means they'll have a different mass. And so that's what we're going to talk about today. So atoms, or isotopes, are atoms of the same element, which means they have the same number of protons, but with different mass numbers due to the different number of neutrons. So they have the same protons but different neutrons, and that's what isotopes are. Now, the atomic mass on the periodic table is an average, again it's an average, of all of the occurring isotopes for that element. And so we'll learn later on how to calculate this average. Now, if you look at the atoms that are on your screen there, we have hydrogen. They're all hydrogen atoms, all right? So the first one is a hydrogen atom. The second one and third one are also hydrogen atoms. However, notice how the masses are different. Even though there's one proton in all of them, the second one has 1 neutron and the third one has 2 neutrons while the first one doesn't have any. And so they're all hydrogen, but they have different masses because they have a different number of neutrons. Now, let's go ahead and talk about the different isotope notations that we'll come across. And so if you see something like this, what this means is that it is a carbon atom with a mass of 12. And so if you ever see, it's called the hyphen notation, if you've ever seen element with a dash and a number after it, the number after it is telling you the mass of the element. And so here's some more examples. So we have carbon 12, we also have carbon 13, and we also have carbon 14. Now notice how carbon 13 and 14 have different masses, but all 3 carbon atoms will have the same number of protons, they just have different number of neutrons. The other notation we'll see is called nuclide notation. And nuclide notation will give you the symbol, and then the atomic number will be the bottom number, which happens to be the number of protons, and the top number will be the mass number. And so if you take a look, this is the format right here. And so some other examples. So well, we have this carbon here, which has an atomic number 6, and if it has a mass of 12, that means we can just subtract it, and it'll tell us that it has 6 neutrons. Here's some other examples. So we have carbon 13, and then we have carbon 14. And notice how they all have the same atomic number. It's just that their mass numbers are different. All right. So pause the screen, pause the video, and just take a look at those different notations. But let's go and move on. All right. If you take a look here, we're going to learn how to properly draw 2 different isotopes. So carbon 12 and carbon 14 are isotopes of each other. Since both are carbon atoms, they have the same number of protons. They have the same number of protons. And so carbon atoms have, well, let's take a look at the periodic table, see how many. Okay, so yeah, here we go. Okay. Let's take a look at the periodic table to see how many protons carbon has. So here's carbon. You'll see that it has 6 protons. And so we look at the periodic table to tell us the number of protons. And so if you take a look, carbon atoms have 6 protons. All of them do. Every carbon atom in the universe. Now, carbon 12 and carbon 14 are different because they have different number of neutrons. All right, so their neutrons will be different. All right, so let's go ahead and draw an atom of carbon 12 and an atom of carbon 14. And so carbon has 6 protons, and if you remember, the protons and the electrons are the same. So for now, we're going to say protons and electrons are the same. Now, if carbon has a mass of 12, and we know that the mass is equal to the protons plus the neutrons, we can then just take our mass of 12 And we know that it has 6 protons, and so that means it must have 6 neutrons as well. So we can put 6 neutrons there. And so let's go ahead and start drawing our atom. And so we know that it has 6 protons in the nucleus. We also know that it has 6 neutrons in the nucleus. And then we can draw our energy levels here. And we can add the electrons. And so it has 6 electrons. 2 electrons will go in the first energy level. The second energy level can have up to 8, but in this situation it's only going to have 4 because carbon has 6 electrons, 2 in the first energy level, and that leaves 4 for the second energy level. And again, this is how we do it. We go 1, 2, 3, 4, and that's what we do. And so if we were to have a 5th one, we would then pair it up with one of the electrons. But you can see that carbon here has 4 electrons in its outermost energy level. All right, so let's go ahead and do this next one. So we've already talked about it has 6 protons and the electrons are the same. However, the mass is going to be equal to the protons plus the neutrons. We know the mass is 14 because it's telling us that it has a mass of 14. And so 14 is going to be equal to whatever the protons are, which is 6, plus the neutrons. And so in this situation, the neutrons must be 8. So there must be 8 neutrons in this situation. And so now what we can do is we can build an atom. And it's going to have 6 protons, because again, every carbon atom in the entire universe has 6 protons. It will also have 6 neutrons. And, does not have 6 neutrons, my mistake. It actually has 8 neutrons. Energy levels here, and we can then add our electrons, which we have 6 electrons, 2 in the first energy level, and then again 1, 2, 3, 4 in the second energy level. And it's that simple. The difference between one isotope of an element and another isotope of an element, if you take a look, it's the number of neutrons, but everything else is the same. And what I will say is that even though they have different number of neutrons, these will chemically behave the same. And so they will have the same properties, they'll behave the same, it's just that they will have a little bit different mass. All right, that's all for this video. If you have any questions, email me. Have a great day.